What's up, astrobiology fans? Understanding the early Earth is crucial for finding life elsewhere. Our planet's atmosphere transformed radically over its 4.5 billion year history, and digging into that record provides invaluable clues. When Earth formed, the atmosphere lacked oxygen. It was likely a mix of volcanic gases like carbon dioxide, methane, ammonia, and hydrogen sulfide. The oceans were anoxic too. It took over 2 billion years before oxygenic photosynthesis by ancient cyanobacteria could oxygenate the atmosphere during the Great Oxidation event around 2.4 billion years ago. But we have evidence that simple microbial life existed over 1 billion years before that pivotal transition. For example, scientists have found fossil traces of methane producing microbes from the 3.5 billion year old Dresser Formation in Australia. An atmosphere rich in methane and carbon dioxide would be a potential biosignature we could detect on modern exoplanets. Another example comes from sulfur isotope ratios in 2.8 billion year old sedimentary rocks from Western Australia. These isotopic signatures suggest sulfur cycling by ancient microbes living in the anoxic oceans long before oxygen appeared. So if we detect an exoplanet atmosphere with abundant methane and no oxygen, rather than writing it off as uninhabited, we'd know to consider it could potentially host a primitive anaerobic biosphere similar to what Earth had for billions of years. And it's not just atmospheric composition. The rock record shows evidence of other factors intertwined with early life, like plate tectonics and nutrient cycles. For instance, the appearance of continents and increased volcanic outgassing around 2.5 billion years ago may have supplied nutrients that allowed more complex microbial ecosystems to take hold. The early Earth gives us a blueprint for the potential stages of atmospheric evolution and global biogeochemical cycling we could witness on living exoplanets. While we can't study them up close yet, advanced telescopes like JWST allow us to take that first crucial step of reading their atmospheric codes and separating possible biosignatures from abiogenic processes. By combining our knowledge of Earth's long journey before complex life with what we observe on other worlds light years away, we vastly increase our chances of recognizing potential alien oases, no matter how rudimentary or unfamiliar they may seem at first. The cosmos could be teeming with life. We just need to know where to look.